Alrighty. Before we've talked about how to use our unit circle to find our 6 functions, our sine, cosine, tangent, and then also their reciprocals, cosecant, secant, and cotangent. Here what we're going to do is we're going to use our domain and range and our period of sine and cosine to determine other values. We're going to be looking at even and odd functions. And if you remember way back when, we had even and odd functions back in lesson 1-3. So big thing you have to keep in mind is no matter how many times you go around your circle, you have a 2 pi revolution. So all these values repeat. If you go around your circle one time, you're at 1, 0. Go around the second time, you're at 1, 0, and on and on. They just keep repeating. All your ordered pairs repeat as you go along. Even and odd functions, remember your even functions reflect over your y-axis and your odd functions reflect over your x and your y together, so over your origin. Cosine and secant are even functions, so if you have a cosine of some negative value, if you have the cosine, say, of negative pi over 2, that's going to be equal to the same value as the cosine of pi over 2. So if you think about where pi over 2 is, if you look at the cosine value at negative pi over 2 means you go around a circle down here. That is a 0. Well, it's going to be the same values if you go around your circle up here. Notice that. Now sine is the negative. Okay, they are odd. Sine is an odd value. So if you have the sine of negative pi over 2, then that means you could have the same thing as a negative sine of pi over 2. So if we look at negative pi over 2, that's down here at the bottom. Go in this direction. That's your sine value is going to be a negative 1. So negative 1 would have to be the same thing as, this is like a negative 1 times sine. So negative 1 times, well, the sine at pi over 2, if you go around your circle, this is a positive direction of pi over 2. Here your sine is a 1. So sine of pi over 2 is 1. Negative 1 times a 1 is negative 1. So notice how these values work out. You have negative 1 equals negative 1. Keep in mind, sine, cosine, tangent, cotangent functions are all odd. Easiest thing to do is just remember that cosine is even, which means its reciprocal has to be even. So if you just remember cosine is even, everything else is odd, you should be all right. So if we think about this as we go through and evaluate our sine and cosine, we need to evaluate here first cosine of 9 pi over 3. Well, this is an improper fraction, so the best thing to do would be to rewrite this as something we might recognize. How about the cosine of 3 pi? Okay, cosine of 3 pi. Well, 9 pi over 3 reduces to a 3 pi. Well, where is 3 pi? So 3 pi would end up being, if you draw a circle, maybe, if you start over here on the right, if you go distance of 3 pi, well, this is 1 pi, distance over here. Back down around is 2 pi, 3 pi is over here. So this 3 pi is going to have the exact same values as the cosine of pi. So if you think about the point at pi, the ordered pair at pi, that is equal to a negative 1, 0. And if you look back at your cosine, is that going to be your x or your y? Sam, what do you think? Boy, you are so not right. Answer would be your x value. So the cosine at pi doesn't want the entire ordered pair, it just wants the negative 1. So your solution for 3a is just negative 1. Now we can use that same thought process here to simplify the sine of negative 11 pi over 2. We got to think about where negative 11 pi over 2 is. Well, negative 11 pi over 2, that's the same thing as saying the sine of, if you divide negative 11 pi over 2, that's a negative 5.5 pi. So that is the same as saying the sine of negative 5 pi plus a negative pi over 2. So we need to go around our circle a negative 5 pi times and then go another negative half over pi. So we're going to, let's use purple here. So now in this direction, this time we're going around our circle in the clockwise direction, there's 1 pi, 2 pi, 3 pi, negative 4 pi, negative 5 pi. So here's negative 5 pi. Now we have to go another negative half of pi. So we're going to end up here at the top. This is where negative 5.5 pi is, which is the same as negative 11 pi over 2. So that means that we are really at the sine of positive pi over 2. So if we want to find the point at pi over 2, we only really want our y value, but the ordered pair there is 0, 1. We only want the y value. So the sine at pi over 2 is a 1. Okay, so let's use for C, here this is a little different problem. It says if the tangent of t is equal to 2/3, find the tangent of negative t. Well, if we go back to look at our values here, tangent of negative t is equal to a negative tangent of t. So we're going to rewrite this as the tangent, let's see, this is equal to a negative tangent of t. So if tangent of t is equal to 2/3, if you put this in parentheses, you're really getting a negative, and then take the tangent of t out and you plug in a 2/3. Here your solution is negative 2/3. And what we did is just used our even and odd properties to help us figure that out. Now down here on the bottom, we're going to do the same thing. And you have to, but we're using cosine. So here you have to remember that the cosine of negative t, well, what's that equal to? Well, if we go back, cosine of negative t is equal to positive cosine of t. So we're going to say if this is equal to the positive cosine of t is equal to this value. So that means your cosine of t is equal to just a negative 1/5. And then finally, we want to figure out what the secant of negative t is. Well, the secant of negative t is just equal to a secant of t. And the secant of t is just a 1 over the cosine of t, so it's just the reciprocal of cosine. So if we take this negative 1/5 and flip that over, you get a negative 5. The last couple examples we won't use as much as we will do A and B, but you do have a few problems like that, so I want to make sure I went over those, and hopefully that'll help you with the couple problems you have for your homework.